In problem 9, we got the following. In the figure, a mass of 31.77 kilos is attached to a light string that is wrapped around a cylindrical spool of radius 10 centimeters and a moment of inertia of 4 kilograms per meter squared. Now it says that the spool is suspended from the ceiling and the mass is then released from rest at distance 5.7 meters above the floor. The question is, how long does it take to reach the floor? So we know that in this problem we have a constant motion of acceleration. So we're trying to look for the acceleration of the center mass. One equation that's going to be useful is the torque being equal to tension times radius, which is also equal to the moment of inertia, and alpha. Now that first part is going to be the first Newton equation because it's representing the rotation of the cylinder. Now in this second figure, there's going to be the second equation, the standard Newton law, representing the translation. So that's represented as the sum of the forces being mg minus t equal ma in the vertical direction. In the first part, we rewrote the value of alpha in terms of acceleration and radius, so we can look for the acceleration, which is what we're trying to find. So we're going to use the first equation to find acceleration in the second equation. In the first part, we got the tension being I times acceleration divided by r times r, or r squared. That's what we plug in here for the tension. And as we continue, we do some algebra and we plug in values so we can get a value for acceleration of the center mass being equal to 0.72. One thing we know from the question is says that the mass is then released from rest at distance 5.7 meters above the floor. So that sentence is represented in this graph. As we can see, y is going to be equal to y initial minus acceleration times time squared divided by 2. So we're trying to find how long does it take for the object to reach the floor. So this is the floor. So we're going to use this equation to find that out, now that we have the acceleration, which we previously found. So if y equals 0, which means that the object is at the floor, we just move this to the side where the y was, and we stay with 5.70. We equal to one another, and we solve for t. We plug in the values. 2 times 5.7 divided by 0.72, which was our acceleration. Then we're gonna get an answer of 3.979. So if we look at the two choices, it could have been B, 3.83, but A is much more closer to 3.979, which is pretty much like 3.98, and that's the final answer.